8th grade math lesson 8.4 is solving systems by elimination, which was the same as the last lesson, but with multiplication. And here's what we mean by that is that question I posed in the end of the last one is, what if they aren't exact opposites, or I can't turn the positive into a negative? What if they don't eliminate? This is the lesson that will teach us the trick to forcing it to, because what you're learning all along is all these math tricks that can help you control the numbers. You're in charge. You're in charge of these numbers. So, and I'll try to keep it smaller and neater this time. Sorry about the messiness from last time. I realized I ran out of room too late. So this time I'm going to try and keep it nice and neat. So I am looking at a system of equations. And in the last lesson, you'll recall, we were looking for a set of variables that have opposite coefficients, or can I alter it to make it negative? But these coefficients aren't opposite of each other, nor are they the same number. These are opposite each other, but they're not the same coefficient. This is a positive 10, this is a negative 5. And then that's not going to matter to me. I need to eliminate variables. So here's how this would work. We're going to use, out of our box of tricks, math box of tricks, the distributive property to force one of these to become an opposite. So when I look at these two, all I would need to do to negative 5 to make him an opposite of a positive 10 is multiply by 2, right? Negative 5 times 2 is going to be negative 10. So I would have a negative 10y here, and that'd be the opposite of that. So we're going to use the distributive property to make that happen. Now remember, I can't just multiply this term by 2 and be like, yay, I'm done. No, if I'm going to change anything in the whole equation, I have to change everything in the whole equation. So what I'm going to do is multiply that whole equation by 2, and I'll use the distributive property to do that. So I will do 2 times 3x, which would give me 6x. And then 2 times negative 5y, which will be negative 10y. And then 2 times negative 17, which would be negative 34. Now I'm just going to go ahead and bring this equation right above here so that they're nice and lined up. I am not changing him at all. Just bringing him down so that now that I've made that adjustment by multiplying all of these terms by 2, look what happens. Now I'm just back at my previous lesson, 8.3, where I can go ahead and eliminate. So I'll add those together. 2x plus 6x is 8x. The positive 10y and negative 10y eliminate. And a positive 2 plus a negative 34 is a negative 32, right? I have $2 in my pocket. I owe 34. I paid 2 of it, so I owe less, but I still owe. Then I'm just on a one-step equation now. I want to isolate the variable x. He's being multiplied by 8, so I'll divide by 8, but I have to do the same to both sides of the equation. X is now isolated. Negative 32 divided by 8 is going to be a negative 4. So now I know that my x is negative 4. Then I will choose one of the equations, one of the original equations, this one or this one, to plug negative 4 in place of x. So I'm just going to go ahead and use this one. 2x plus 10y equals 2. Plug negative 4 in for x now. And now I will go ahead and just solve for y. First, I'm going to do 2 times negative 4, which is negative 8. Bring down what I haven't done yet. Just do one step at a time so your brain can see what's going on. My goal is to isolate y, so I will pull this constant away. Opposite of negative 8 is positive 8. Now I've got y being multiplied by 10. Inverse of multiply by 10 is divide by 10. That isolates y by itself. 10 divided by 10 is 1. So my solution is x is negative 4 from here, and y is 1. So if we graphed this equation and this equation on a coordinate plane, the point at which they would meet would be right there, at negative 4 on the x and 1 on the y. So a lot of this process is the same as the previous lesson. The only change we're making to it is the manipulation of getting getting the opposites. If they weren't opposite or easily opposite there, you can make them opposite by using distributive property. Let's look at another one. Okay, here is my system of equations. These are my two equations. Let's look at them up and down and the like terms in terms of what I can eliminate. I have a 5x and a 3x. Those won't eliminate. I can't easily turn the 3 into a 5 without doing something to the 5, so not my first option. A 2y and a 6y, both positive. I could change this. If this was a negative 6y, that would be an opposite. And I could, if I multiplied this by a negative 3, then this would become a negative 6. And so you kind of use that same skill you used when we were using like common denominators, right? You start seeing those numbers the same way. So if I multiply this by negative 3, it can become a negative 6 and it will be an opposite. So let's go ahead and do that. Let's multiply the whole equation. I can't just multiply one term in the equation. I have to do the whole equation times negative 3 for this. That's the number that's going to get what I need. So that will go to each term. So we're using the distributive property for that to be multiplied by each term in the equation. Negative 3 times 5x will be negative 15x. Negative 3 times positive 2y is going to be negative 6y. And negative 3 times negative 10 is going to be a positive 30. All right, that distribution is done. I'm just going to bring this down right below here again, just so I have them nice and lined up. I'm not changing anything in this one. I just want it to be nice and lined up for me. And now I have it all set up for elimination. Because I was fair to every term, I haven't really changed anything. I just went ahead and adjusted all of them. If I change just one, I've messed it up. It has to be all terms that are affected. Now I can go ahead and add those together to eliminate. Negative 15x plus a 3x. That's going to be a negative 12x. I owe 15 x's. I have 3 that I'll pay. I still owe 12. Negative 6y and positive 6y cancel each other out. And 30, positive 30 and a positive 66 is going to be 96. Now I'm just using inverse operations to solve for my variable. X is being multiplied by negative 12, so I'll divide by negative 12 to both sides of the equation. That is going to give me x equals a positive divided by negative is negative, and 96 divided by 12 is, I think, 5 or 6. Let me do the math. Way off, it was 8. So 96 divided by 12 is 8. Okay, so there's my x now. I know that this x part of my solution is a negative 8. Now I will plug that into either of my original equations. I can choose one. I'm going to go with this one. 5x plus 2y equals negative 10. And just to keep it nice and neat and my brain figuring things out, I'm going to rewrite it over here so I can have a fresh start. And instead of x here, I'm going to plug in negative 8. 5 times negative 8 plus 2y equals negative 10. 5 times negative 8 is negative 40 plus 2y equals negative 10. I haven't done anything with those yet. Now my game of isolating my variable by doing inverse operations. Start by inversing that. The opposite of negative 40 is positive 40 to both sides of the equation. That will leave me with 2y equals negative 10 and a positive 40 will be a positive 30. I owe $10. I have 40. I could pay 10 of that back. I still have $30 left. Now y is being multiplied by 2. The inverse of multiply by 2 is divide by 2. Y equals 30 divided by 2 is 15. So the point where this line on a graph intersects with this line on a graph is going to be at negative 8 on the x coming from there and 15 on the y coming from here. Okay, we'll look at one more on this and then we'll go on to the next part where they say solving a system by multiplying and subtracting. Kind of is the same thing though, but I'll get to that. Let's just look at one more example like this. So I'm going to go ahead and investigate. Okay, can I easily make opposites here? Not really. I could, but I'd have to do stuff to both of them. How about here? Sure. Yeah, I could make this negative 1y be negative 2y if I multiplied by 2. So I'm going to go ahead and multiply the whole equation by 2. Every term in the equation will have to be multiplied by 2, or else I'm changing it in a wrong way. It's gotta be changed equally throughout. So 2 times 3x is going to be 6x. Negative 1y times 2 is going to be negative 2y. And 2 times negative 8 is negative 16. So I've made that adjustment to every term. I'm going to just bring this equation down just so that it's right next to it again, nice and clean and neat. And now all I have to do, now that I have those opposing, I've manipulated it so that I have opposing terms that I can eliminate, I'll add this all together. 4 plus 6x is 10x. I should say 4x plus 6x is 10x. A positive 2y and a negative 2y eliminate each other. A positive 6 put together with a negative 16 is a negative 10. I have $6 in my pocket. I owe 16. I'll pay the 6 out of the 16 and I still owe 10. Now I'm just isolating my variable. It's being multiplied by 10, so I divide by 10 to both sides of the equation. X becomes a negative divided by positive, which is a negative. 10 divided by 10 is 1. Now that I know what X is, I can plug it into either here or here on either of these equations. I'll go with this one. This is 4. I'm going to rewrite that same equation over here just to give my brain room to see. And I will plug in for X, 4 times X, which is negative 1. I know that now. And there we go. 4 times negative 1 is negative 4. I'm isolating the variable now, the variable y, by using inverse operations, starting with the opposite of negative 4, which would be positive 4 to both sides of the equation. That cancels. 2y equals 6 plus 4, which is 10. Y is being multiplied by 2. Inverse of multiply by 2 is to divide by 2. Must do to both sides of the equation. 10 divided by 2 is 5. Y equals 5. So the solution, the point at which this equation graph and this equation graph will intersect with each other, is where x is negative 1 and y is 5. So my answer will look like that. All right, the next section talks about how to solve a system by multiplying and subtracting instead of adding. But it seems to me like the easiest thing is to just deal with the opposing sign right up front and then just always add. Otherwise, my brain gets very confused. So if you kind of use it the same way, then it should work out the same way, because subtracting is the same as adding a negative. So we're just going to use that same thing. So if I look at my x's coefficient, my coefficients on my x variables, I have a 6 and I have a 2. These are positive. And over here on my y's, I have a 5 and a 4. Well, I could more easily, the easier way is to have this be not a positive 2, but a negative. And if I multiply this 2 times a negative 3, it's going to give me that negative 6 that I'm after to be the opposite of this. So what I'm going to do is use distributive property like we did in the example just before this. But in order to keep this, so what they're going to do in your example in your book, I should say, is they're going to just multiply everything by 3, and that's going to be a positive 6x, just like this. But they're going to subtract the two equations from each other. That will work. That will work. Usually what I do is I just take care of that negative right up front, and I say, I'm going to go ahead and multiply the whole thing times negative 3, because then it becomes the opposite that I want. So I'll do the negative 3 times every term in this equation. Negative 3 times positive 2x is going to be a negative 6x. Negative 3 times negative 4y is going to be a positive 12y. Negative 3 times negative 26 is going to be a positive 78. Positive 78. Now, just to line these up nice and neat, This has been adjusted, it's been amended, so I want to line this one up nice and neat with this one. So I'm just going to rewrite this right above it. My brain likes that. Okay. And now I have my perfect opposites, so I'm just going to add them together now. Positive 6x and negative 6x cancel. Positive 5y and positive 12y is positive 17y. And 7 plus 78 is 85. Isolate the variable, use inverse operations. Isolate the variable y. He's being multiplied by 17, so I will divide by 17 to both sides of the equation. That leaves me with y equals 85 divided by 17, which is 5. So now that I know what y is, I can choose either of the original equations to plug that into. I'll just choose this first one here. I'm going to write it off to the side. Keep things nice and neat as much as I can. Now I'm going to substitute in place of y. I'm going to put 5 because now I know that y is 5. So it will be 5 times 5 equals 7. I'll do that multiplication. 6x plus 25 equals 7. And now I'll do inverse operations to isolate this variable, starting by getting rid of this positive 25. Opposite of that, or inverse of that, is negative 25 to both sides of the equation. Positive 7 and a negative 25. I have 7, I owe 25. I'm still going to owe, I'm going to owe 18. Still inverse operations to isolate my variable x. He's being multiplied by 6. The inverse of multiplied by 6 is divide by 6, both sides of the equation. Negative divided by a positive is a negative. 18 divided by 6 is 3. So the point at which these two equations would intersect would be at negative 3 on the x and 5 on the y. So that's how you do that. So you could do the same thing and not deal with the negative here. And then when you got down to here, you would just do subtraction. I just went ahead and dealt with the negative here and added the negative. Subtraction and adding a negative are the same thing. So whichever you prefer. Okay, I think it's a good time for a pause and try it and then see how you did. So if you are feeling adventurous, go ahead and write this one down, pause, and you try and see how you do. And then push play when you get stuck or when you've solved it to check it. All right, I am looking at my terms. I have a 3x and a 6x and a negative 7y and a negative 9y. If this was this, I could turn into a negative 6x if I multiplied by negative 2. 3 times negative 2 would be negative 6x. So I can make this one an opposite of this one. That's what I'm going to do. I will multiply the whole equation times negative 2. So negative 2 times 3x will give me negative 6x. Negative 2 times negative 7y will be a positive 14y. And negative 2 times a positive 2 will give me a negative 4. And I went ahead and wrote it just below this one. They're right next to each other now, so I will just add them together, because these are now opposites. So they cancel, they eliminate. I have a negative 9y and a positive 14y. I owe 9y's. I have 14, so I'm still going to have some left. I'm going to have 5 left. 5y. And I have a 9 minus 4, or a 9 plus a negative 4. 9 minus 4 we know is 5. Isolate my variable by using inverse operations. It's being multiplied by 5, so I will divide by 5. Must do to both sides of the equation to keep it balanced. 5 divided by 5 is 1. Now that I know what y is, I can choose either original equation, plug y in, and solve for x. So I'm going to choose this one. 3x minus 7y equals 2. Substitute for y, the 1. Negative 7 times 1 is negative 7. Isolate the variable using inverse operations. Opposite of negative 7, positive 7 to both sides of the equation. 2 plus 7 is 9. X is being multiplied by 3. Inverse operation is divide by 3 to both sides of the equation. 9 divided by 3 is 3. There's my solution. The point at which these two equations will intersect if you graph them is at 3 on the X term and 1 on the Y. There's your answer. How'd you do? I hope you did well, or if you made an error, I hope you saw what the error was, because we learned from those two. Let's look at that word problem. Okay, let's read it first. Underline the question, circle the information they gave us, helps us sort things through, right? The Simon family attended a concert and visited an art museum. Concert tickets were $24.75 for adults and $16 for children, for a total cost of $138.25. The museum tickets were $8.25 for adults and $4.50 for children, for a total cost of $42.75. How many adults and how many children are in the Simon family? That's our question. How many adults and how many children? So we have two unknowns, the amount of adults and the amount of the children in the family. And so that's what our X and Y are going to be representing, is those unknowns. I don't know how many adults. I don't know how many children. That's what they want me to know. So we'll identify that. Let X equal the number of adults, and let Y equal the number of children. And in my head, I start thinking things like, I hope I get whole numbers and not decimals or fractions, because we were talking about a whole person. The answer needs to be in whole people. We don't cut people in half. So that's something in your brain that you could start paying attention to. So if you calculate through and you get a fraction when you're looking for, or a decimal when you're looking for a whole person for your answer, then maybe there's an error in there somewhere. If it was money I was looking for, that's fine, because we have quarters and nickels and dimes and stuff. But we're not looking for money here. We're looking for how many adults, how many children. So that's just something I kind of notice when I'm working on stuff like that. Well, let's see what information we have that we can use. They went to a concert, and the adults were $24.75 for that ticket and $16 for a children's ticket. The whole cost was $138.25. So we went to a concert, and it was $24.75 for one adult ticket. We don't know how many adults were there. We've called it X. So times however many adults were there, add to that the cost of the $16 for one ticket for a child, times we don't know how many children. We agreed to call that Y. But the whole amount was $138.25. That's the equation for the concert. Now let's look at the equation for the museum. They had museum tickets, $8.25 for adults and $4.50 for children, for a total of $42.75. Okay, so $8.25 for an adult ticket. I don't know how many adults are going. $4.50 for a children's ticket. I don't know how many children are in that family. It's the same family, so it's the same amount of adults and same amount of children in each of these, for the total cost of $42.75. That is my system with my two equations, my equation for the concert and my equation for the museum. Same families going, so in both equations it's the same amount of adults and same amount of children. All right, none of these look like they can opposite eliminate, right? They can't. But I'm looking at this. 8 times 3 is 24, and 25 times 3 is 25 cents. Quarter times 3 is 75 cents. So if I multiply this by 3, it's going to be $24.75, but that would both be positive. So instead of multiply by the positive 3, what if I go ahead and multiply by the negative 3 to make this a negative $24.75? Let's multiply the whole thing times negative 3, and I'll be using my calculator for this. Feel free to use your calculator for this. We're going to multiply every term in that equation times negative 3. So 825 times negative 3 is going to give me negative 2475x plus, I'm not even going to put plus there. I take it back. It'll depend. I have this positive 450y times negative 3, so we'll do positive 450 times negative 3. It's going to be a negative 1350. And then I will do a negative 3 times positive 42.75, which will give me a negative. Positive times a negative is a negative 128.25. That is the amended equation when I multiply by negative 3, so I could get that opposite of that. Let me just take this equation and rewrite it right down here so it's lined up nicely. I'm not making any changes to this one. I'll even write it in the same color as it was originally. Okay, here's my new one with that adjustment I made, my new system. And if I add those together, these two cancel each other. They eliminate each other. That was my goal. I have a positive 16 and a negative 1350. So 16 minus 1350 is 250. Oops. Don't forget that y. And 138.25 plus a negative 128.25. That's a subtraction, simply straight through. That's going to be 10. Okay, now I'm just isolating my variable by using inverse operations. It's being multiplied by 250, so I will divide by 250 to both sides of the equation. 10 divided by 250 is 4. No fraction, no decimal. I don't have half peoples. That's good. Y equals 4. Y was my number of children. There are 4 children. Now that I know there are 4 children in the group, I can use that information in either equation to help me solve for how many adults there are. I think I'm going to go ahead and use this one. It has smaller numbers to deal with, so I'm going to use this original equation before I went and manipulated it. Okay, so I've rewritten this one here, and now I'm going to plug in, instead of the y here, I'm going to plug in the 4, and then I will calculate. So 825x plus 450 times 4 equals 4275. 450 times 4 is 18. Just bringing down the stuff I haven't done yet. Now my goal is to isolate the variable x by using inverse operations. Start by getting rid of positive 18. That's negative 18, both sides of the equation. That leaves me with 825x equals 42.75 minus $18 is 24.75. Variables x being multiplied by 825. Inverse of multiply by 825 is to divide by 825. X equals 24.75 divided by 825. And that is 3. Good thing it's a whole number because we're talking about people again. There are 3 adults. X was representing my adults. So that is how you could go through and solve that. With practice, it gets easier. There's a lot of pieces to that. Will we make errors? Yes. In fact, I made an error in the middle of that lesson somewhere and had to delete half of it and redo it because of a negative number, and I got myself messed up. And that happens. That will continue happening. Just watch very closely. Try and keep it as neat as possible, and be aware of those positives and negatives. Just be careful, but don't feel bad if you occasionally make a calculation error. It happens. So good luck with that. Take your time. Let me know if you need me.